Okay, so state whether each of the following mapping diagrams represents a function. Give a reason for your answer in each case. So the reason for the answer is always going to be the same, right? So is this a function? Yes, it is. Why? Because every input has exactly one output. Job done. Now, what about over here now? Is this a function? No. Why? Because look, every input, and this is what the way I want you to start thinking about it. Every input does not have exactly one output. And if you're going to say no, maybe give an example. For example, look, the input A has two outputs. And then that's kind of, unarguable with them, right? So let's look at these two. Is this one a function? Number 3 here, what do we think? Okay, and I just want to maybe labor the point here a little bit with you. Look what I'm doing here. I'm actually going to copy this and paste it. And this is what I want you to get into your mind. The questions are all the same. This is not a function because every input does not have exactly one output. For example, what is it? The input 9 has two outputs. Now let's look about this one here. Is this a function? Well, let's play around with it. Let's look at the domain. The domain, the set of possible inputs. You can see that's P, Q, or S. Let's look at the codomain. We're only playing with this now, just a little bit of revision. Possible outputs, A, B, C, and D. The range, let's look at the range. That's the set of actual outputs, A and C. Does every input have exactly one output? Yes. Every input has exactly one output. So it is a function. Okay, so, just to get clarity, I suppose, if you're asked if something is a function, the answer is either going to be number 1, yes, it is a function because every input has exactly one output. Or number 2, this is not a function because every input does not have one output.